All right, folks, we are recording now. So, good morning, good evening, good afternoon, everyone, from wherever you're joining in. I believe everyone's from India. So, good morning, folks. And my name is Prithvi Raj. I'm also part of the co-organizing team of the KCD Bangalore 2022 happening on the 23rd of April. I hope everyone is registered for that as well. And we are glad to welcome you all to this Chaos Engineering 101 workshop with the Litmus Chaos team. And we'll be going through a lot of things. I mean, we'll not keep it till one, of course. We won't want to stretch it a lot, but we'll be covering a lot in chaos engineering. I think it's a new topic for everyone. A lot of people wants a hands-on demo on what exactly Litmus Chaos is, or how exactly you run your chaos experiments. But this is going to be an interactive session, and I hope you all ask your questions. Feel free to post your doubts, and you have a learning session along with us. So moving on, let's just start with a quick introduction about us. As I said, my name is Prithviraj. I've been leading the community efforts for Litmus Chaos since the last 2 years. It all started off at Maya Data back in 2020. And to give you a history of this project, what this project it was not even a project. It just started off as a project to test another tool set altogether, which is based on cloud native data management, that was OpenEBS. And soon, in a year or so, we believe that chaos engineering can become a project. A lot of people just believe that, why adopt chaos engineering? Is it worth it? So we'll be talking about that. But yes, of course it is worth it, and that is why it became a project. And since my data to chaos native, and now at Harness, we have been investing heavily on chaos engineering, and it's an amazing prospect. And everyone in the future, I think everyone will be talking about it, and it's growing now exponentially, but it will become something which will be part of all the enterprises, and even the developer persona will be using chaos for their testing purposes. And other than that, I've been working as a co-organizer at various events: KCD Chennai, Bangalore, Chaos Carnival, another chaos engineering conference, and obviously we organize chaos engineering meetups every last Saturday of the month under the CNCF ecosystem. So Nilanjan, perhaps you can just go ahead and introduce yourself.
Thank you, Prithvi. So hello, everyone. My name is Nilanjan. I'm currently working as a software engineer in Harness, and before that, I was also working at Chaos Native. So basically, at Chaos Native, my role as a software engineer was to develop new Chaos experiments. So basically, in my day-to-day life, what basically goes on is I come forward with different chaos engineering scenarios. I inspect the requirement of these chaos workflows that we can create in order to simulate different kind of outage scenarios, and then basically I integrate them within the Litmus Chaos environment. So yeah, I'll be sharing my experiences today about how basically outages can affect your system, and how Litmus Chaos can basically help you against these outages. And yeah, basically that's mostly about me.
Thanks a lot, Nilanjan. So let's move ahead with the agenda for this workshop, what we'll be talking about and what all we'll cover for you. If there's something we do not cover, then feel free to let us know any aspect that you want to talk about, and we'll open the floor for questions in between as well. So first of all, obviously we'll be talking about what chaos engineering is, how resiliency drove the idea of chaos engineering, and what exactly are the principles of chaos. And then moving on, we'll just introduce a little bit of Litmus Chaos to you. What's the journey been like? How the community is? What sort of help you can get from the community? And then then thirdly, we'll talk about the architecture. How is Litmus Chaos built? What are the core components of Litmus? How you can understand them, and then advantages and disadvantages. Of course, I mean, there are not a lot of disadvantages, but let's say anyone is interested in any sort of comparison, or you want to know why Litmus Chaos should be a tool that you should look upon, then feel free to ask that question. The roadmap, obviously, we are building it as a community, so we need to focus on the roadmap cumulatively, and then how you can contribute, how you can be the part of this ecosystem, this community. And then lastly, we'll just take you through the cloud and give you a quick demo. So let's get started, folks. For this workshop, at number 1, chaos engineering, a closer look. So before I talk about chaos engineering, let's just talk about what resiliency is and how chaos engineering was brought into place. I think a lot of you might have heard about it already, and a lot of you might not have heard about it. And being part of this Kubernetes ecosystem, or Kubernetes in itself, has a lot of possible vulnerabilities. There is a possibility that a pod might go down, a node might go down, or there is here are some examples that we have taken, that a pod is evicted from a node, or a node goes to a not ready state, or there's a memory leak in a container. So there are so many possible outages that can happen in the day-to-day world when you're working with Kubernetes. And it being dynamic already, there are so many dynamic changes that are happening, enhancements that are happening day in and day out. And even with the load, I mean, there are so many factors that lead to an outage. So what happens when there's a possibility of a vulnerability or an outage? There are two possibilities, right? Either the system stays resilient, that is, the pod is rescheduled and the dependent service is healthy, or the node is again, in spite of a not ready state, the system is working, or even if there's a memory leak in a container, you don't face a possible outage. But let's say that the dependent services get slow, or you are not able to work around it, then obviously there's a possibility that that's an example of a weakness, right? And that is where we differentiate between a weakness and how the systems are resilient. Obviously, resilience is the ability of a system to stay afloat. Let's say any fault happening and the system still stands up, then that's obviously an example of the system being resilient. But if it goes down, then you have to identify that there is a weakness, there is a possibility that your system might just lead to a downtime or an outage, and that leads to companies losing millions and billions of dollars. So as you can see, there are some expensive outages as examples that we have taken. Facebook, Instagram, WhatsApp just went down a few days ago, and they lost millions in the stock market, and as well as because of this outage in internally as well. And there have been so many outages over the past few years. Slack has seen some outages. We've been using all the social media platforms, Twitter, Amazon, Reddit. Massive internet outage brought it down. There was a DNS error. Or DoorDash and PSN again became the backup because of AWS going through an outage. And there have been, I mean, financial companies, banking sectors, you talk about banks, they are looking at solutions to possible outages. I think American Airlines went through an outage, Delta Airlines went through an outage a few years ago, AWS has gone down. And these are the possible outages that have literally caused downtimes. They have led to these companies losing billions in revenue. And outages are expensive. They are really expensive if you not take care of them as and when needed, or if there is not a solution to them beforehand. And these outages last for hours and hours if not found a solution. And that is why chaos engineering was brought into play by Netflix back in 2011 and 12, where they believe that there can be a possibility of, why not test the system before this outage happens? Why not actually induce these kind of faults or chaos when before such sort of an outage happens in real time or in the real world? And that is where chaos engineering came into place. It was obviously, it started off with Chaos Monkey at Netflix, and chaos engineering was just the process of inducing a fault deliberately into the system, or a real world outage into the system, to identify what will happen when the fault actually happens, or when the outage actually happens. And then create a system which can withstand these unexpected disruptions, or which can basically withstand any sort of outage that is happening in the system. And that is what chaos engineering it's just a process of testing a computing system, a complex system, to ensure that the resiliency of the system is maintained when such real world scenarios happen. So why chaos engineering? Why do you need chaos engineering? There are a lot of folks who want to ask, or who want to know that what is chaos engineering, or why is it required. So this is an example of an application. We have taken this example a lot many times, that an application is in form of a pyramid. how does an application behave. It's just not your application, but there are other dependencies as well, and these are the dependencies that are out there. I mean, there are your application dependencies, for example, your MongoDB, I mean, the database, your Kafka, there are Postgres. I mean, there are so many dependencies that your application has under the layer. So the first layer is your application, of course, the topmost layer of the pyramid, and then there are your application, that there's your application layer of the dependencies. And then, yeah, there are your cloud native services. There are so many open source projects as well, Core DNS, Envoy, Prometheus for your monitoring, OpenEBS again for your data. So that's the third layer. And then there are the Kubernetes services running, and then there's your infrastructure layer. So I mean, your application itself is divided in 5 layers or more than that, who knows. And each and every layer has its resiliency dependencies. Every layer, there's a possible of an outage in every layer, and there's a need to test each and every layer. I mean, there's a pod that can go down, there's something that can go down in a Kubernetes service, or that, let's say, your any other service, there are possible outages happening because of enhancements happening every day. I mean, let's say your OpenEBS is a cloud native data service was enhanced, uh, and there were some new features that was added, and then suddenly it went down, which actually led to the whole application going down. So I mean, how can you even depend on one particular factor, right? You have to depend on each and every layer, and that is where chaos engineering comes into play. It predicts each and every possible scenario that can happen each and every layer. People are testing their UI, people are testing their data management services, people are testing their VMs. So chaos engineering was necessary because the applications are dynamic, they are changing every day. Each and every dependency requires testing, and that is where chaos engineering comes into play and tests your application from top to bottom, because that is how the dependencies increase, that is how the requirement for testing increase in a top to bottom way. So, I mean, too many applications, as I suggested, can affect the resiliency of your system because it's a dynamic world. They are changing, and you need to constantly validate the resiliency of the entire system with not just Kubernetes applications, but with non-Kubernetes applications as well. The ones who are using legacy systems, bare metal VMs, they are also requiring a lot of validation and testing, which chaos engineering brings in. So where in the DevOps loop comes chaos engineering? I mean, there are a lot of people believe that it's on the dev side because testing is part of the dev side, but we believe that chaos engineering is more on the ops side of things, where you deploy, where you monitor, where you operate. So the feedback loop in the DevOps side gets activated by testing in production. The eventual goal is to test in production. With chaos engineering, you just don't want to. I mean, a lot of folks talk about pre-staging environments, staging environments, and of course, chaos engineering can be used anywhere in the DevOps cycle. They can be used, I mean, when you're building, when you're testing, when it's in the staging phase, or when it's in production. But the eventual goal is to ensure that the systems stay resilient in production. So the feedback loop gets activated by testing in production. So how do you do chaos engineering? What exactly are the steps? How do you follow the exact way of chaos engineering? But before that, I would just like to cover a little bit on the principles of chaos engineering. So there's a website out there, you might be aware of the same, that is principlesofchaosengineering.org. I think that's a very famous website. A lot of folks have been checking it out here and there to just identify what the principles are, just check out what exactly chaos engineering is and how is it run. So obviously, as I had already mentioned, it's just the discipline of experiment to build confidence in your own system so that you can withstand turbulent conditions. But how is it practiced, or how is chaos engineering practiced? And these are the principles of chaos engineering. So the first step is, and the first and foremost step is by defining the steady state of your system, or by identifying how the system is when it's normal, or when it indicates normal behavior. So you need to define that, define the output of your system when it's in steady state, and then you need to hypothesize around it. Then you need to identify that how the steady state will continue. I mean, that you divide it in two groups. One is the control group and one is the experimental group. The control group is the group with which basically indicates the normal behavior of the system, or the normal experiments that happen here and there. But the experimental group is where you experiment with your system. You try to introduce various faults in your system. You try to induce any sort of real world outage. And that is where the hypothesis comes into play to create the various real world events. That's the step three, where there's, let's say, a network connection problem, or there's your servers crash down, or there's issue with scaling. I mean, for example, the biggest example that we can take here in India is an example of a big billion day sale, or let's say the Great Indian Amazon festivals that happened during the festivities, where websites like Amazon, Flipkart, and other e-commerce platforms just give out sales. And there's a huge there's a huge demand of users who come in, and the applications need scaling. They need to act according to the number of users, or even if there are a lot of transactions happening at that point of time, it needs to act properly. But that is introducing a real world event, or a possibility of an outage, right? There is a possibility that due to this amount of users or transactions, the system can go down. And similarly, these real world events are introduced as variables, a part of the experimental group, to affect the system, or to basically induce a chaotic scenario in the system. And then you keep on testing the system, and let's say if the systems still are resilient after that fault, then you go on to a new experiment, a new sort of a real world scenario, and you keep on testing until you understand the systems are resilient, and it goes on in a continuous loop. But let's say the system is not resilient, and there's a fault, there's an outage, the system goes down. So again, you move on, you fix that system, you fix that weakness, and then you introduce that fault again. So it goes on in a loop. And that is where the step four comes on, where you try to disprove of the hypothesis by looking for a difference in the steady state between the initial stage and the later stage, that is the real world scenario. So these are the steps. As I mentioned, they are just briefed out, where your real world events, you run your experiments in production, and then you automate them. I mean, obviously, chaos engineering today, the ecosystem of chaos engineering is such that people are running them manually. Chaos engineering is being run manually, and folks are still focusing on that. But the eventual goal is obviously automating them. You don't want to run them at a particular time, or you don't want to run a particular experiment according to your need and run them manually. Rather, you want to automate them, and the experiments should run according to the need of your application. They should be scheduled through the interface itself. So obviously, chaos engineering helps build automation into the system. And the last goal is obviously minimizing your blast radius, because experimenting in production has its own demerits, cons. There is a possibility that it can cause you unnecessary pain, unnecessary negative impact. And that is one of the reasons why chaos engineering, people are skeptical to adopt chaos. They are scared of chaos engineering, and they are not ready to go ahead and ensure that chaos engineering comes in as a practice. But it is the responsibility of an obligation of the engineer practicing chaos to ensure that you minimize the blast radius, you contain the experiments, and they are experimented in a careful environment, so that chaos engineering, in spite of being a powerful practice, becomes a boon rather than a bane. So going back to the slide deck that we have, we as I mentioned, these are the steps in which chaos engineering or cloud native chaos engineering is practiced. You identify the steady state of the system, you introduce a fault. If the SLOs, I mean, SREs were the initial persona that started introducing chaos in the system. So as an SRE, you need to ensure that your SLAs, or your, I mean, SLOs, SLIs are managed. They are continued to be met. So if they are continued to be met, then obviously your systems are resilient. But let's say there's a possibility, or there's a weakness that is found, then your systems are going to be, I mean, they are not going to be resilient anymore. So at this point of time, I would just open the floor for any initial questions we have about the introduction, and then we'll move ahead.
Just one question: how you will covering actually how to introduce fault in the system, or how it will be?
I didn't quite get you. Can you please like?
No, means if I want to introduce a fault into the system, or how the tool will have options to provide fault to the platform? Means generally
Yeah.
how you do actually, or you will be covering
Yeah.
later actually?
Yeah. Okay. So
Yeah.
let me
Okay.
explain. As part of chaos engineering, we basically abstract the entire chaos engineering process into four simple steps. So these are basically those four steps that we are trying to cover. First of all, you basically identify your steady state condition. This is only on a logical understanding basis. I mean, this is not part of the actual LitmusChaos tool. The process of doing it in actual tool will be showing you that as well, but just for your sake of understanding, just try to understand them as four separate processes. In the first process, you basically go and just identify a steady state condition. Like you have your, let's say, your Kubernetes cluster, and it is having, let's say, a certain number of pods as part of a deployment. So that happens to be your steady state condition in which you want your Kubernetes cluster to stay always, or ideally be, so that it is functioning normally. After that, you hypothesize that even if I introduce a fault, a certain kind of a fault, this steady state condition should be persistent. And that is the proof that our cluster is basically resilient, because we don't want that any kind of an fault should alter our steady state and make our Kubernetes cluster more prone to failure. That is something we would not want, because that makes it more likely for the cluster to go down in the production. So we basically create that kind of a fault. We inject that fault within our, let's say, our Kubernetes cluster, and then we basically match the outcomes of the chaos injection, that whether even after the chaos injection our cluster is basically, let's say, is able to return to its original form or not. Like, let's say if we are deleting the two pods, then throughout those pods, like is there, let's say we have some kind of a deployment here, so is that deployment still reachable while we are deleting a certain percentage of the prods? This is one of the experiments that we'll be actually doing today. So that's how you basically go on testing by introducing the faults. That is the idea behind chaos engineering. So think of it as a vaccine. What we do in case of a vaccine is basically we inject some kind of a fault to make our bodies more resilient against certain kind of a virus or certain kind of a weakness that we might be affected in the future. So here we introduce a fault in order to in order to understand what can basically go wrong in the production if there is some faulty condition or any kind of a weakness that is in our cluster. So that is the idea. uh, am I able to answer your question, Krishna?
Yeah. Means just I wanted another question I was having is that if there means see I know I can reduce the number of pod or some of the thing means and we see this how the stable the system is. But either the tool or is there any guidelines actually? Okay, these are the things we do supposed to do actually so that to check the resiliency of the system, or is there anything like that, or
Okay.
the based on the product only or the design only we have to come up the resilience scenario?
Okay, so this is actually the expertise of a DevOps engineer or even a chaos engineer, you would say, who is on the forefront of designing these chaos workflows, which can actually reveal the actual kind of weaknesses that a system might have. What LitmusChaos provides are experiments. You can think of experiments as the building blocks of the chaos workflows. You can combine different kind of experiments over a chaos workflow that can actually expose these weaknesses. But as far as it goes, that which experiments that you should be actually practicing and which not, that is something dependent on a case by case approach. In fact, it is very much recommended that we should always take each chaos engineering scenario on a case by case approach to get the most out of a to get the most results out of chaos experimentations. See, the thing is that whenever we are performing these chaos experiments, it's like we are exposing a new set of weaknesses every time, because the conditions are always changing, and it's like always making sure that we are hitting the right kind of weaknesses that we are trying to find. What I mean to say is that, let's say you have a certain number of pods in your application. Now, if you have that many pods as part of a deployment, if you decide to kill all of them at once, then certainly your service is going to go down, or basically your let's say your endpoint will not be reachable. So that is something you would not want, of course. But you need to basically be judgmental of what is a real life scenario which can actually affect our systems. It can be anything from a simple DNS to something like a network chaos. Anything can potentially affect your system. So you would have to be judgmental of it on a case by case approach. But what Chaos does is it provides you all the different experiments, starting from network to DNS to IO to and that too on a different blast radius scale. That is, you have pod based experiments, node based experiments, and now even cloud based experiments and machine based experiments.
Yeah, thank you. Thanks.
Sure, Krishna. Prithvi, would you like to go ahead?
Sure, Nilanjan. Thanks a lot, Krishna, for your questions. I think moving on, we'll cover them as well with the project and with the demo and talking about the project as well. So I think with this, we talk about how chaos engineering is practiced today. I mean, folks who are practicing already might get an overview of how chaos engineering is typically done. But this is not how chaos engineering is supposed to be done all this while. I mean, game days is I think one of the most important ways of practicing chaos. This is a must. Folks today are conducting game days. That is nothing but running a chaos engineering test suite or some multiple tests workflows according to the application to just understand application behavior, or just to understand how the system will run when chaos is induced in a system in production. And that is where the findings are noted down. The findings are taken in consideration to basically identify if the chaos engineering tool or a particular project is something that can be used or not. But other than that, it's still rarely integrated into the CI/CD, although chaos engineering is must for the CI/CD of a system. Let's say there are adopters in form of talent who are using chaos engineering in their CI pipelines. They are using Litmus Chaos with Jenkins. But as of now, it's still rarely integrated into the CI/CD of the system. And there's a belief that only the SRE persona is something is the one who can practice chaos engineering, but that's not the case. I mean, being part of the community since the last 2 years, the developer persona has also been engaging in chaos engineering. There is a paradigm shift where developers are moving into practicing chaos, and it's not just for the DevOps or the SRE persona, but chaos engineering is slowly becoming a must for each and every persona. Just run a test, just for the development purposes, for the testing purposes. Everyone is for, I mean, QA engineers. There are so many different personas that are slowly starting to use chaos engineering, but that's the current scenario. And obviously there's manual planning and execution behind it. I mean, as I said, it's a lot of manual labor that is involved, but slowly the steps are being taken towards automating this, and everything becomes part of an automated process. I mean, observability is not a commodity. You need to observe your experiments. You need to find out how your experiments are run, what is going down, how your systems are behaving. You need to check the charts, the graphs, which show in where is where there is a spike, when there is a possible outage, where there's a downtime, where there's an uptime, what exactly is happening. So each and every enterprise obviously has a custom built stack, and if someone are using Dynatrace, someone's using Datadog, but observability is still key, and people want to check out their logs. They want to manage, I mean, monitor what exactly is happening. They want to manage them all together, and slowly it that is becoming the part of the test suite. So chaos engineering doesn't just come with running these tests and finding out the fault, but it also comes along with monitoring them, checking out the logs, checking out what exactly is happening in the system. And obviously there was a custom measurement process to manage and see how reliability is functioning, but with, scaling and GitOps coming in as helping to scale these systems, I think the measurement process has absolutely changed, and now chaos engineering is coming out of all these practices, and rather these practices are being reversed, where it's integrated into the CI/CD of the system. Developers are also jumping in to practice chaos. Automation is taking place. The UIs of various chaos engineering tools out there are helping automate these tests. Observability is becoming a must. Everyone is integrating their chaos engineering tools with, let's say, Prometheus, or they are visualizing them on the Grafana dashboards or on their Datadog, Dynatrace. These platforms are using chaos in a huge way at the measurement process to find the resiliency scores, to basically find out the reliability. Scale your systems have also become great with GitOps and all these practices coming in. So these are the founding principles of chaos or cloud native chaos engineering. As we talk about, we believe in open source. Open source is the future. It's the key to develop chaos engineering. We need to identify inputs coming in from the community. We need to add experiments that come in from the community. Let's say from the banking sector, we have learned a lot from the use cases. From the e-commerce sector, from the automobile sector, every other sector or enterprise has a different use case, has a different input that can come into chaos engineering or cloud native chaos engineering, and that is what we have believed in. With that, we have built the Chaos Hub. So let me just take you through the Chaos Hub. We could have introduced that before, after introducing Litmus, but just understand what Chaos Hub is. It's the marketplace where you can find all the different experiments that you want to run. Your infrastructure is based on Kubernetes. That is what Litmus started with. It was based on a Kubernetes. It was a Kubernetes community chaos engineering platform. And slowly we shifted to other non-Kubernetes scenarios as well. AWS, you can test your applications, Kafka, CodeDNS, Cassandra. You can test on cloud. You can test your other cloud native applications just as OpenEBS. And there's so much more coming out based on Crossplane, Vitess, and Open Policy. So there are so many applications that need to be tested. But as of now, you have got tests for your VMs, your Azure, so that is what a chaos hub is, and that is something that is contributed by the community. The community comes in, tells us what sort of experiments do they need. They contribute themselves. They make these experiments better, what can be done in terms of documentation or in terms of the experiment run itself. So that is what the chaos hub became, a marketplace for all these experiments, where you can pull one of these experiments to run them in your application or create a chaos workflow. And as Nilanjan mentioned, a workflow is nothing but different chaos experiments running in parallel or series according. It's a chaos engineering test suite run according to your needs or the needs of your application. And observability, as I mentioned, it's key. You pull in your metrics, your Prometheus metrics, and visualize them on your dashboard. It can be a Grafana dashboard or any other dashboard where you visualize. And again, you need to visualize, so that's important. And then there's GitOps. So you need to scale your experiments. You need to identify how, from where you can pull in your experiments, how you can pull in experiments from different scenarios. You need to scale them so that they run according to your requirement. So that, I think, that was the most important integration that we had as a chaos engineering tool. And then open API and lifecycle management. Obviously, an open API is something that has helped run chaos for non Kubernetes scenarios as well. And that is what cloud native. When we talk about cloud native, a lot of people believe that it's just Kubernetes, but slowly shifting to the non Kubernetes paradigm or the legacy systems has basically defined our foundation principles that chaos engineering is for everyone. And we believe in the chaos first principle. That is why induce a fault when the system goes down. Why not induce it beforehand? Why not check your systems before the fault? happens. And that is what brought in Litmus Chaos, the chaos engineering tool set. It's a CNCF incubating project. That means it's in the second stage of the CNCF ecosystem. It's an open source chaos engineering framework with a cross cloud support, which helps you induce chaos in your system easily. It has an amazing UI, which is called the Chaos Center, which helps you visualize your experiments, schedule them, run a chaos workflow, identify the reliability of the system, run the chaos probes. There is so much to it, and it's an amazing, it's a popular project which is really popular in the community. There are 1200 plus Slack community members who have been running Litmus. It started off way back in 2018, and since then, in this 4-year journey, it has become a project which has been adopted by several organizations, from e-commerce giants to I mean financial companies and rest others you can check out on the website. But that is how Litmus came into play, and that is where Litmus is today, and every other developer or SRE persona is believing in the toolset and contributing back to it as it's open source. So where in the DevOps pipeline, or where in the DevOps ecosystem you can use Litmus Chaos? A lot of folks believe that it can just be used in the production environment, but as I mentioned, it can be used everywhere. You can use it in your CI pipelines, in your pre-staging environment, for your long-running tests, in your pre-prod, and as well as your production environment. So everywhere you can induce chaos in some form, or for faults in some form. And most of the folks are actually starting off with the pre-staging or staging environments. That is what we have learned from the community, and then moving on to production. So these are some project stats that's just for your reference, how it has grown. And you can see the chart, it's grown exponentially. There are 50 plus experiments that are out there available on the Chaos Hub. Almost we are reaching 500,000 operator installs and more than 850,000 experiment runs. There must be more, who knows, but this is the project growth. As you can see, I mean, by 2020 it was just starting to grow, and we hadn't even reached 100,000 experiment runs, but today it has just grown to reach somewhere around 900,000 experiment runs. And that is what has helped this project become a go-to chaos engineering tool, something that can be talked about in workshops and other places as well in the community. So we are now in the 2.7 version of Litmus Chaos, and Litmus Chaos, I mean, Nilanjan will be covering the features and everything about Litmus, but this is what is exciting about Litmus Chaos, or the current space of Litmus Chaos, where the what are the characteristics, or what are the functionalities that are provided to you. I mean, there are a lot of features in 1.x, that is the Chaos Hub, which allows you to, I mean, bring in predefined experiments. You don't need to write them. But Litmus 1.x also had an SDK which helped you write your own experiments. So let's say there is some experiment which is specific to your application, or which you want to induce to your application, and that is not available on the marketplace or the Chaos Hub. Then using the SDK which is available in Go and Python, you can write your own experiment. You can just write something specific, you can contribute it back to the community, and you can use it by yourself. And let's say there are other chaos engineering tools out there, like for example Chaos Toolkit, and there is some experiment that is available with Chaos Toolkit but not with Litmus Chaos. Even you can use that with the Litmus framework, so you can basically bring in that experiment and use it using Litmus Chaos. So there were some amazing features which 1.x provided in terms of security, resiliency, in terms of being user friendly. But here are some other exciting features. I mean, you get a user management and teaming process. You just don't have to use it for one member, but your whole team, as in, I mean, if there are 5 folks in your team, or there's a company full of folks which want to use Chaos, then there's an ability for teams to use the same. The Chaos Center is the UI which helps make it easy. You don't need to run or type out a lot of experiments. Just copy paste those YAML files or run them one by one, but the Kiosk Center helps you create the workflows easily. And there's a resilience score calculation, which helps you calculate the resiliency score, how resilient your systems are, how well the probes run. The probes are nothing but the custom health checks, which help identify the reliability or the resiliency of your systems. There is monitoring and observability, which is available inbuilt in the Kiosk Center. Where you can just pull out your metrics, and you can observe what is exactly happening in the system. The workflow editor helps you edit your workflows. You can create them in series or parallel. The GitOps functionality helps you scale your systems, bring in your own experiments or run them accordingly. And there are so many, I mean, abilities that Nilanjan is going to cover moving ahead. But this is a quick overview of what chaos engineering was and what exactly Litmus Chaos is in layman's definition. And with this, I think we'll cover more on the architecture. We'll cover more on what exactly Litmus is and how do you define everything, how do you get started with it. And I'll perhaps ask Nilanjan to take the floor from here. But if there are any questions, perhaps we can just give a couple of minutes to any sort of questions as of now, and then Nilanjan can move ahead.
Hey, Prithvi, this is Sandeep. Just quick question, right? Apart from Litmus, right, how exactly are the other tools placed to validate the chaos engine? Like Gremlin is what I heard initially when I did my initial start. And what is difference and what is Mesh Chaos when compared to Litmus Chaos?
Sure, Sandeep. So, I mean, there are a lot of chaos toolsets out there. I'll just take a few names. One of them is Gremlin, as Sandeep mentioned. Chaos Mesh, it's another CNCF project. There is, I mean, Chaos Blade, Chaos Monkey, Chaos Toolkit, SteadyBit. I think these are the mostly the chaos, and Litmus Chaos, of course. So these are mostly the famous tool sets out there available. So I'll start one by one. Chaos Monkey was a tool that was developed by Netflix back in 2012. It was just to run some basic production related tests, a CPU attack or something. And since then, the development of this project, or according to the world, how it has changed, how Kubernetes has come up, as relevantly been slow. So Chaos Monkey is something which folks did not adopt with time, or which became a little bit redundant with time. And then the other tools are pretty much out there. They are pretty much unique in their own ways. As Sandeep mentioned about a couple of tools, Kiosk Mesh and Gremlin. So I'll talk about Gremlin first. Gremlin again is an amazing tool. I'm sure they are doing a great job. But I think the few limitations that it has is, number one, it's a closed source tool. So you don't get the benefits of being open source. I mean, community contributions do not come here. So there doesn't come a lot of understanding with what the community understands. Then there are a lot of functionalities which Gremlin might not provide you. Let's say the option of I mean, probes, or let's say the Chaos Hub. There is no marketplace that Gremlin has, or there is no custom health checks that Gremlin provides. But I'm sure Gremlin also has certain things better. I mean, in terms of experimentation, maybe learnings from the community that closed source project take from their customers. And certain attacks, let's say black hole attacks, or some attacks. And similarly, Chaos Mesh, I think it provides the benefit of being open source. It's a project I mean, simultaneously with Litmus Chaos. It's also part of the CNCF space. And there are so many things which differentiate Litmus and Chaos Mesh altogether. Again, as I said, probes, the marketplace, Chaos Hub, I mean, GitOps, and these are a few things which the Chaos Mesh might not have. But again, Chaos Mesh might have certain experiments, let's say JVM Chaos or HTTP Chaos, which are yet to be a part of the Litmus Chaos. I mean, Chaos Hub, or which are yet to be part of the Litmus Chaos test suite. But I mean, every Chaos toolset has its differences. Some tools are great with VMs. I mean, if you run Litmus with Kubernetes, then I don't think you'll have a complaint here and there. If you run Chaos Mesh with a particular application, then it is great. But I think it's all about identifying what suits best to you. And it's also about the community. I think, I mean, being part of the community, I can say more than the tool, I think what is important is community support. I mean, you can run a tool, but chaos engineering is new for everyone. Everyone is just getting started with chaos, and a lot of help is necessary in terms of community support for someone to get started with chaos if they are not opting for, you know, an immediate enterprise support or something of that sort, which enterprise support providers are already giving you. So in terms of that, I think Litmus Chaos becomes a standout, or the community support is something which comes into play. The various use cases are something that everyone in the community learns from, and if you are a part of it, you'll get to know that how the community drives this project to help you understand the various functionalities, get you started quickly, and make it easier for you to, you know, induce chaos or bring in chaos as a practice. And these are I think a rough, I mean, difference between these tools. If you go into the depth, I think there's a lot out there in the community, but I think you'll have to use each and every tool a little bit deeply, or have a POC on all of them to basically identify which is the best tool for you. I hope this answers your question, Sandeep.
Hey, thanks, Rutu. Yeah, that's thanks for the update. Yeah, and one more thing I need to shout. Since I'm using Litmus from past 2 months, right, I'm being very impressive with the community and the Slack response how I get. So in that case, I'm quite happy at least to start exploring and taking it to my organization as such.
Appreciate the acknowledgement, Sandeep. Thanks a lot.
And one more thing, since we have a very strong ISG team, the recent one from incubation state to the sandbox to the incubation state, which was helped us a lot for getting approval for ISG to go to the stage and prod environment for sure. That was a very good from the Litmus and end users perspective.
Thanks a lot, Sandeep. I think with incubation, we obviously are focusing on graduation now, but obviously it's a long journey. But I think with incubation, there will be a new roadmap which will be coming into place, and open source. I mean, Litmus Chaos is going to see a lot of contributions coming in, and I hope, Sandeep, from your end as well, we'll see some amazing contributions both on the technical side, the tool set side, as well as on the community side with blogs, videos, and anything that is possible.
Sure, Prithvi. Thank you.
All right, thanks a lot, Sandeep. Do we have any other questions? All right, folks, feel free to ask your questions in chat, and whenever we open the floor for questions, we look forward to them. With this, I'll allow Nilanjan to take it ahead, and Nilanjan, the floor is all yours. I'll stop sharing.
Yeah, thank you so much, Prithvi. All right, folks. So let's try to deep dive a bit into what enables Litmus Chaos to become such a awesome chaos engineering tool set. What I'll do is basically lead you through this architecture of the Litmus Chaos. I'll try to keep it less verbose so that you just get a gist of what's under the hood of Litmus Chaos. So the entire application, or like the entire architecture of the Litmus Chaos, can be divided into two sections. First is the chaos control plane, and the second is the execution plane. So what you interact with is the chaos control plane. That is the front-facing user component with which the user usually interacts in order to either schedule their own chaos experiments or chaos workflows, or configure their observability dashboards, so on and so forth. So usually everyone has one chaos control plane using which they can control multiple chaos execution planes. What I mean is, say that you are installing Litmus Chaos into your own Kubernetes cluster. Of course, you have a self agent over there. That is, you can inject chaos within that particular cluster. But at the same time, you can also inject chaos into other Kubernetes clusters as well. That is something is enabled using the Litmus agent. So the Litmus agent enables the installation of Litmus execution plane components within your external Kubernetes clusters, and then we can connect those agents using our chaos control plane in order to inject chaos within them as well. So moving ahead, within the chaos control plane, you can see that we have, first of all, our chaos center. The Chaos Center is a combination of three components that we have. First is the web UI, of course, which we use in order for basically injecting chaos into our Kubernetes components. Then you have the Litmus API. The Litmus API also does the same thing. You can use the Litmus API, the GraphQL API, in order to inject chaos into your various Kubernetes components using the API. And then you have Litmus CTL. Litmus CTL is a command line interface for injecting chaos in a declarative manner, or basically controlling a few aspects of your chaos center using your CLI. So the way it does all this is using, of course, an auth server as well as a GraphQL server. The auth server, as the name suggests, is responsible for the authentication of the various requests coming in, while the GraphQL server is the backend server that handles the connection between the chaos execution plane and the chaos control plane. And it is also aided by a MongoDB, a NoSQL database in which we store the different information, such as, let's say, user details or the chaos result for different chaos workflows that we run, so on and so forth. So the GraphQL server then is in communication with the different chaos execution planes. And if we go inside the chaos execution planes, the very first thing that we see is the Litmus agent infra. So what is the Litmus agent infra? Well, as I mentioned, that Litmus agent is responsible for setting up the chaos execution plane. And within this agent, we get, first of all, the most important part is the subscriber. The subscriber is what sets up the entire agent. It is responsible for communicating the messages, the logs, the error messages, etc., back to the GraphQL server, and ensuring that the server is in a healthy state whenever you are restarting your Kubernetes cluster, or basically whenever you are setting up your Kubernetes cluster. So while the subscriber is there, there is also something known as a workflow controller. The workflow controller, or the Argo workflow controller, is basically it is basically a controller loop, a Kubernetes controller, which looks out for the workflow custom resource. Now, what is the workflow custom resource? Well, what happens when you create a chaos workflow from your chaos center is that it is nothing but a long manifest, which is a Argo workflow custom resource. So that workflow custom resource manifest is simply passed on by the GraphQL server to your chaos execution plane, where the workflow controller reconciles the state of your Kubernetes cluster according to what has been defined inside your workflow custom resource. So let's say that you have your different chaos execution steps inside it. You have 2 experiments or 3 experiments in serial or parallel. All that can be actually be mediated by the workflow controller. Don't worry if you're not completely able to grasp it. We'll be seeing a hands-on demo of the same in a short while. So after we are basically getting our workflow custom resource, we are having the different Litmus Chaos custom resources, such as the Kiosk Experiment and the Chaos Engine. Chaos Engine is responsible for remediating the step of the Kubernetes cluster, which is being actually done by the chaos operator. The chaos operator is the heart of the entire chaos execution plane, and it is what is driving our chaos injection efforts within the Kubernetes cluster. So the Chaos Engine custom resource is what is being sought by the chaos operator. And once it gets the Chaos Engine, it basically reconciles the state of the Kubernetes cluster as per the Chaos Engine CR. So what I'm trying to say is that, let's say the Chaos Engine CR contains the various steps to inject chaos within our cluster. Like if we want to delete a pod, or if we want to do something like a network chaos experiment, the Chaos Engine CR will contain all the details of that particular experiment. That is how to basically perform that experiment, and that is being reconciled by our chaos operator. And the Chaos Experiment CR contains the low level details of these experiments, including what is the image that is we are using with our experiment, or like what is the environment variables that we are using in order to tune our experiment, so on and so forth. So yeah, this is basically a brief overview of the Litmus backend execution infra, where the actual experiment execution happens. We left out on 2 important components in the agent infra as well. First is the event tracker. Okay, so what is an event tracker? Well, the event tracker helps you to declaratively define your ideal state of a Kubernetes cluster in which you would like to trigger a chaos workflow. So it works something like this. You basically write a event tracker manifest. This event tracker manifest will continuously look out for the current state of the Kubernetes cluster. So let's say that at any point of time, your Kubernetes cluster's conditions or basically specifications matches that what has been defined in our event tracker. Like for an example, in a particular namespace for a particular deployment, we should have a certain amount of pods. Only then execute this workflow. So this kind of a condition can be defined using the event tracker. Finally, we have the Kiosk Exporter, and the Kiosk Exporter is being used by the Prometheus in order to fetch the different metrics of chaos of the applications, or basically the chaos of the LitmusChaos basically while our chaos injection is taking place. So don't worry, I'll be basically showing you how you can use Kiosk Exporter in order to create the different observability dashboards for your Kubernetes cluster. Moving forward, let us try to deep dive a bit into the different components of LitmusChaos, what we understood so far. So first of all, you have the chaos center, that is nothing but the Litmus control plane, and the chaos agent, which is comparable to the execution plane. While I've already explained the significance of both of them, again, the chaos center is the front-facing user component from which you control all the activities happening inside your LitmusChaos in order to inject chaos workflows into your Kubernetes cluster, while chaos agent is responsible for setting up your execution infra and within your Kubernetes clusters. Moving forward, we have the LitmusCTL. So as I explained, LitmusCTL is nothing but the CLI for LitmusChaos 2.0. It is used for setting up the various aspects of Litmus. If you're setting up your LitmusChaos center, it can help you by helping you set up the agent and do a few user management stuff, so on and so forth. Moving forward, we have the multi-cloud support with LitmusChaos 2.0 as well. So what it means is that you can basically install LitmusChaos into any of these clouds. Basically, any cloud that has Kubernetes, you can install Litmus into it using your LitmusCTL as with a chaos control plane, or even as a external agent using the LitmusCTL. So let's take a deep look into what are the core features that are being offered by the Litmus. So these are again the same features that we have been discussing right now, but I'll shortly go over each one of them, give you a brief of what they look like and what is the particular use of that feature within the Litmus. Starting with the chaos center, you have your chaos workflows. So when I say chaos workflows, think of chaos experiments first. The chaos experiments are nothing but the building blocks for chaos workflows, and chaos experiments by themselves represent a certain type of a failure, which you can inject in your target resource. So you can use all these different blocks in sequence, in a particular sequence, whether that's serial or parallelly running experiments, to create complex real world chaos scenarios, which are known as chaos workflows. So although it sounds complex, but believe me, it is a very simple process that can be actually be achieved using your chaos center, as I'll show you in a while. Then you have the option for creating these chaos workflows from templates, or from using custom workflows directly from scratch by using the experiments from Chaos Hubs, or even pre-created YAMLs you can directly upload. Next, you have the different control, that is the Chaos Experiment sequence control. As I mentioned, you can have the experiments in serial or parallel. You have the choice of creating your own defined chaos scenario using this LitmusChaos. Finally, you have the schedules. So you can also run singular workflows, or you can set them as clone workflows so that they will keep on running based on a particular schedule. Finally, you have the experiment priority, that is, while calculating the resiliency score as per the outcome of every single experiment in your chaos workflow, you can attach weightage to a particular experiment, so that, let's say you want to provide more weightage, more importance to a particular experiment as compared to another, you can set up a priority or chaos, basically wait for it, resiliency score. Moving forward, we have the workflow management. So you have GitOps. So GitOps is basically rolling out automated changes using GitOps. there is actually two types of GitOps that we have here in Litmus. That is, first is the front-end GitOps and the back-end GitOps. The back-end GitOps is what I explained you earlier. It's the event tracker that we use for automated workflows, while the front-end GitOps refers to Git as a database. Like what we do is we store all our Kiosk workflows within a Git repository, and will be always fetching the workflows from that particular Git repository as well. So what it does is that Git becomes your single source of truth for all your workflow runs. And there is, if you make any of the changes inside your Git, inside the manifest that is stored in the Git, it will help to run the automated changes, run a workflow using those automated changes here in Litmus as well. Then you can also use your custom images. That is, let's say you have a custom image registry from where you want to pull all the different images required for the LitmusChaos. You can certainly do that. You also have the option of setting a resiliency score in order to understand how resilience exactly is your Kubernetes cluster for a chaos workflow. Then you have options for multi-tenancy. As Prithvi had explained, we had introduced multi-tenancy as part of LitmusChaos 2.0. You have scope support, that is, you have option for the control plane and agents can be run in both in a cluster scope as well as namespace scope mode. So what happens is in cluster scope mode, you can inject Kiosk into each and every namespace inside your Kubernetes cluster, while in namespace scope mode, basically you can inject Kiosk into only one namespace. So this helps in reducing the blast radius so that you don't accidentally affect your other applications while doing some chaos. Then you have strong authentication support. Well, basically you can authenticate your LitmusChaos using OAuth by using DEX support. You can authenticate with Google or GitHub for your teams. You can also choose basic email and password that is of course there. And then you also have options for creating teams, so that let's say that you want to run a particular set of chaos workflows as a team, you want to explore the causes of failures as a team. So you can certainly do that. You can create your own team, invite your team members, accept the invitations, and collaborate over you creating your chaos workflows and exploring chaos engineering with them. Then you have fine-grained RBAC controls. Well, what happens is flexible RBACs are used to drill down and grant correct privileges to the users. So you have full control over what you're trying to do inside your Kubernetes cluster. Let's say that you want your experiments to have a certain permission, or let's say not have a certain permission. You can go to the RBAC for that experiment and then change your privileges to basically only have that sort of permission and don't let any additional permission apart from it. Then comes the monitoring and observability. So observability is something that is very much important in chaos engineering, because only injecting faults is not enough while you're doing chaos engineering. You need to be always able to gain feedback from what you're doing and understand that what is making your system slow, or what is making your system less resilient. So therefore, observability is not a separate commodity in here in Litmus. We treat it as a first-class citizen, and it is inbuilt as a feature within the LitmusChaos. So starting with what are the different features that you get out of observability. First of all, you can connect your own data source. Currently, we only support Prometheus, but in the future builds, you'll be certainly seeing Datadog as well as more data sources for your for connecting different data sources. Then you have the visualization capabilities. That is, whenever you're running your workflow, you can see them as aggregated modules, schedules, basically, so that you can make a sense out of what is working and which step is not working. Then you can compare different workflows. Of course, what went wrong, you can find out that using that. Then you can upload your own dashboards. Like, let's say when I'll show you within LitmusChaos that how we are creating interleave dashboards, so you'll be able to see that you can create create your application dashboards, store them. Then you can again upload those dashboards basically in order to create a seamless experience within your different LitmusChaos centers if you have multiple them. Then you can tune your dashboard. So What we mean by tuning your dashboards is that you can have different sorts of graphs as well as different sorts of metrics that you can monitor for using these dashboards. So monitoring everything doesn't make sense. Therefore you can only select those dashboards that mean the most to you and to monitor your chaos in the real time. Next is GitOps. So as I explained, there are two types of GitOps. First is the Git as a DB, that is the front-end GitOps. And then you have the event trackers, which is the backend GitOps, which can basically run an GitOps LitmusChaos workflow automatically when a certain condition is validated within your Kubernetes cluster. Then you have your non-Kubernetes chaos. Well, this is something that we have been working with some vigor since last few versions, that is whenever since our LitmusChaos 2.0 has released. So as the name suggests, we are not right now limited to only Kubernetes chaos. We can inject chaos into machine scope resources. We can inject chaos into different cloud based resources, including public clouds such as GCP, AWS, or Azure, or even private clouds like VMware, as well as we can attack our bare metal nodes, nodes using IPMI based out of band access experiments. So yeah, basically that's non-Kubernetes chaos in a nutshell, which we'll be further exploring in today's demos. Finally, here's a bit of diversity of the different experiments that we have as part of LitmusChaos. You have pod-based experiments, you have node-based experiments, you have different network experiments within the Kubernetes sphere, you have different kind of stress chaos experiments that spans across the pod and node blast radiuses. And then we have different cloud service experiments, such as AWS based experiment for EC2 stoppage, or like AWS EBS detach, just detach. Then you have application based chaos as well, like Kafka based experiments or OpenEBS experiments. And latest to this addition is a machine based experiments as well. That is, we go within a VM, try to interact with the OS based resources such as processes or CPU of a virtual machine, so on. So yeah, with that, let's talk about a bit of the future roadmap. So of course, we are committed to providing more non-Kubernetes infrastructure components, because as we understood non-Kubernetes, it is not always the case that your Kubernetes cluster is perfectly cloud native. You might be trying for an ideal cloud native solution, but you might have certain legacy systems, certain legacy bare metal clusters, or your own data centers that are also right now hosting your legacy applications. So in this case, you cannot just move to Kubernetes and cloud native ecosystem. You still need to validate your chaos engineering use cases for your legacy applications, and that is something non-Kubernetes non-Kubernetes chaos experiments will enable you to do. Then we are also looking forward to more application specific chaos experiments with native faults and health check. And definitely it's in the roadmap for, of course, as Prithvi mentioned, we are looking forward to various cloud native applications such as Vitess, etc., in which we are planning to inject faults and bring them out as chaos experiments for Litmus. Next, we have the Kiosk SDK. Well, the Kiosk SDK is what helps developers to write new experiments. So we are certainly planning on to improve the support for it. Just to mention, like what Kiosk SDK is, currently we have it for Go, Python, as well as Ansible, and it helps you bootstrap a new Kiosk experiment, so that as a developer, you are only responsible for defining the core logic of the experiment and nothing more than that. Next, we are also planning to have more probe types. So if you're unaware of what LitmusChaos probes are, stick with me. I'll be showing you inside the Litmus portal that how you can define probes and what it does. But in a nutshell, probes are nothing but a declarative way of validating your chaos hypothesis in an automated fashion. So let's say you have an hypothesis as part of your chaos workflow. You can automate the process of its validation using these probes. So we have different types of probes already, such as CMD probe, HTTP probe, PROM probe, KTS probes, and we'll be adding more in the future. Moving forward, we also have the we are also pledging for improved observability suite for the Kiosk experiments. With the current observability suite, you can definitely have interleave dashboards for your different experiments, but we feel that that is not enough. We need also support for different more types of data sources. Moving forward from Prometheus, we also are looking forward to integrating Datadog or other types of data sources, which will be beneficial for us. And finally, we are also pledging for more chaos types, that is more chaos experiments. While it is a continuous process, but we still feel the requirement at every meetup or at every fixed interval to mention the different types of chaos experiments that we are working on. So that is something that you can certainly look forward to. So how you can contribute? Well, there are a host of features that you can contribute to when it comes to Litmus Chaos. Just visit our Kiosk Slack and we can set you up with what kind of contributions you can do. Otherwise, you can also visit to the GitHub pages, the GitHub repository of Litmus Chaos, where you'll find all the different kinds of issues that you can get your hands dirty with. So Prithvi can help you more in this regard, or you can just let us know at the end of the workshop and we'll help you get started with the contributing. So with that, we have come to an end of our presentation. And I would encourage you guys to please ask any of your questions you might have so far before we actually go on to the demo and see Litmus Chaos in action. Okay, then let's just go to our demo. Let me first go to my Kiosk Center. So for those of you who don't know what Kiosk Center is, well, Kiosk Center is your front-facing user component where you can inject kiosks, as I explained in the presentation. And as part of this demo, we are going to run 3 Kiosk workflows today. So what are these Kiosk workflows, or basically what are we going to do? Well, first of all, I'm going to show you a Kubernetes-based Kiosk experiment, and it is one of the most popular Kiosk experiments that we have here, known as a pod delete experiment. The name itself should be enough to explain what we are going to do. We are going to basically delete a few pods of an application and see how it affects our application. After that, we are going to see a multi-cloud Kiosk workflow. What we are going to do is we have a bunch of resources in our AWS cloud, in our GCP cloud. I'm going to show you that how you can basically get started with deleting these resources. You can see that how we can basically go ahead and kill these resources, or basically stop them, detach them, how we are designing an entire multi-cloud chaos workflow spanning across AWS and GCP. And finally, I'm going to show you a machine-based chaos experiment using mAgent. So I'll be explaining you what mAgent is or what the workflow does while we are getting started with our experiment. So at any point of the workflow, if you're not sure that what I'm doing, or if I'm not able to correctly explain what I'm able to do or what I'm going to do, please feel free to unmute yourself and ask. That would be completely fine. So with that, let me just show you how you can first of all schedule a workflow here, or maybe I can just give you a brief tour of what the Kiosk Center is and what are its different features. So this is the home dashboard where you can see the number of agents you have, what are the projects that you have. Then you can see the different past workflow runs if you have run past workflows. Then you can see the Litmus workflows panel over here. It also shows the past workflow runs as well as any schedules that you might have. So as I had explained to you that you can run the different chaos workflows in a schedule using Litmus Chaos. Then you have the Litmus Chaos agents. Well, the Chaos agents is what enables you to inject chaos either into your own cluster using a self agent, or into your external Kubernetes cluster using an external agent. So I currently don't have any external agents. All I have a self agent over here, as you can see. So you can connect n number of agents using Litmus Chaos, which effectively means that you can inject chaos into n number of Kubernetes clusters using a single control plane. Moving forward, we also have Kiosk Hubs. So Kiosk Hubs, as Prithvi had explained, is a marketplace, an open source marketplace for different chaos experiments that you have. You have the standard Chaos Hub provided by Litmus, that is the Litmus Chaos Hub, which is like the standard Chaos Hub with every like you will be always having access to this. But apart from that, you can also create your own chaos hub. So let's say that you are using Litmus in your organization and you are creating custom experiments. You can have your own chaos hub where you can add the different experiments and maintain it in order to basically in order to separate them from the actual like open source chaos hub, since this will be your private experiments for say. Next up, we have the observability. So as I told you, observability is a common commodity in the Litmus Chaos world. We treat it as a first-class citizen because observability is deep-rooted within the chaos engineering practice itself. So what it can do is it can basically show you the different workflow statistics, like what are the different workflow runs that you have over a duration of time, what are the failed and the past workflows, uh, and you can basically filter them based on the different criterias. You can see the different periods over which you are basically going to like have your workflows. Then according to the agent itself, there are so many options actually to configure. Then you also have your data sources. So as part of this demo, I've already set up a Prometheus data source. I've set it up and connected it with Litmus. So what it does is it helps you create different application dashboards. So for example, we have a sock shop dashboard over here. I'll show you how it will be helping us. But before that, let me just give you a sneak peek into what it is doing. So as you can see, we have different application metrics observable using this observability tool. And all this data is actually directly being fetched from your Prometheus over here. So you can create interleave dashboards using different options here. Moving forward, basically this is it in a nutshell, like what Litmus it is. You can again play with different settings. There is option for GitOps setup for custom image registry, but I'll leave you up to it to explore sometime. With that,
this dashboards, right? Is it something we need to export the dashboard from Prometheus, or we need to create our own dashboards over here?
Okay, so the idea is that the dashboard, the monitoring dashboards are supported by the Prometheus because you need something kind of a time series database or some type of a data source from where you will fetch in your different metrics. So the way it works is, if you remember, I'll just go back to my slide deck. We have something known as a Kiosk Exporter over here, right?
Correct.
So what Kiosk Exporter does is, while your experiments are running in your Kubernetes cluster, it fetches all those different metrics while your chaos is running, and these metrics are basically being fetched into a Prometheus database. The Prometheus database is then storing these different metrics, which becomes your single source of truth for basically setting up your monitoring dashboard. So that is the idea behind it. You are having different applications with yourself, and you're having your own Kiosk Exporter. You can have your own like you can have a Litmus Chaos Exporter, of course, but even if you have, let's say, a Node Exporter or Kubernetes Exporter, Kubernetes State Exporter, you can also integrate them within this dashboard and create an interleave dashboard. So that basically will help you to understand that what is the impact of chaos while you're running it. Like, let's say Node Exporter is for seeing like what is the status of a node, different metrics like CPU, IO, latency, etc. Kubernetes Exporter is something of a similar line for Kubernetes. So all of this information will help you understand in a better way that while you're injecting chaos, what is going in with my system? Why why is some queries having a greater latency than other? So this kind of information will help you gather information about your system and make your system more resilient. Does that answer your question?
Yes, but like one thing is, see, I already have an external Prometheus which is being configured for the app. Is it the same metrics, or is it different specific to kiosk testing metrics have been captured?
Okay, so yeah, we are capturing different metrics as well, but you can use your same Prometheus database here as well. The idea is that the Kiosk Exporter gets installed as part of your Kiosk execution plane. Let me just hop into my terminal to give you a better idea of what I'm saying. So if I say kubectl get let's get all Litmus. So I'm going to show you that what all is actually getting installed as part of your LitmusChaos installation in your Kubernetes cluster. Everything gets installed in the Litmus namespace actually. So I'm doing get all in the Litmus namespace. So the idea actually is while we are waiting for it, like the idea actually is that you have your Kiosk Exporter. The Kiosk Exporter is nothing but a Prometheus exporter, which exports the different metrics from Prometheus to basically your not from the Prometheus, excuse me, from your Kubernetes regarding your Litmus Chaos execution to your Prometheus. So these execution metrics include chaos results, chaos, different chaos workflow summary, basically. Just a quick confirmation. Prithvi, am I audible?
You're audible, but we're seeing your presentation.
Yeah, right. Not sure what is happening. Why I'm not able to fetch my Kubernetes information.
The only reason why I'm asking this is take an example, right? We have two
Yeah.
clusters. One cluster is where all our DevOps components like Kiosk is also there, and in other components where applications are getting deployed. So this exporter, I wanted to check if it's something which we need to deploy even in the application time, or it will only try to do it because it has to. Someone has to pump that metrics to this particular export Prometheus, right?
Yeah.
Which we get installed along with the Chaos UI.
Yeah.
So
Okay.
I had that doubt.
Okay, so as I understood that you're asking that who is basically responsible for pulling all the different metrics from like your chaos metrics from the Kubernetes cluster. Am I understanding it correctly?
Yes, to this Kiosk exporter.
Through this chaos exporter. Okay, so as you can see, I just listed down all the pods in my Litmus namespace. I'm not sure why get all is not working, but anyway, get pod it. So as you can see, chaos exporter is actually installed within your Litmus namespace by default. What it is doing is it is actually fetching all the different information that is that is actually related to your Litmus chaos, and it is being stored right now inside my Prometheus DB. So you as a user don't need to do anything. In fact, you just need to install LitmusChaos and that's it. If you already have Prometheus installed, that integration will be taken care of directly while you're integrating Chaos Exporter and setting up your dashboard over here. Like what you need to do is before setting up your dashboard is basically connecting your data sources. So in overview section, you will have actually an option to create your dashboard, like sorry, adding a new data source. So right now, as you can see, only one data source is added. So as in your case, like if you'll have a Prometheus data source, you can simply add it over here, and you already have Chaos Exporter over here. So you just need to set your data source up with this Chaos Exporter and you're good to go. Nothing more than that.
Got it. Thanks.
Yeah, sure. Okay, I'm not sure what is happening. Some real life chaos, it seems. My Kubernetes UI is, sorry, the terminal is lagging a bit, but I'll try to show you what's happening over here. All right, with that, let's just jump into our first chaos workflow. So with this first chaos workflow, it will be a simple experiment. It will be a pod delete experiment. So what we are going to do is that, but before I go ahead, let me just delete a few pods over here so that it will be easier for you folks to see what we are doing over here. So actually, these are all the previous experiment runs that we have, different pods related to that. I've just forgot to clear my dashboard. So let me just delete all this before we actually go ahead. So I hope we can meanwhile get started with creating our workflow while the deletion is actually taking place. What are we going to do? Well, let me just introduce to an application that we have. It is known as Sock Shop. So who doesn't love socks? Well, even if you don't, let's just pretend for this demo that you do. So what is Sock Shop? Well, it is an e-commerce application, an e-commerce website for selling socks. So the special thing about this application is it is basically completely a microservice application. It is managed by a host of different microservices, and each part of this application is actually a microservice, including this catalog or including this home page that you're seeing or including the cart that you have. Everything is a microservice. Even the users, like you can do login and stuff, that is also a microservice. So what we are going to do is basically it has a catalog section as well. We are actually going to delete that catalog. So what I mean by deleting the catalog is, let me just show you basically that what the catalog looks like in the Kubernetes. So if I say kubectl get deployments, that's in sock shop, my application is actually deployed in the sock shop namespace. So let me just fetch the different deployments for you. As you can see, we have the different deployments. Catalog is one of them. It has 2 pods currently that are running as part of this deployment. So what we are going to do for this experiment is, of course, it is not representative of a real maybe like scenario that you might have, but we are going to do is we are going to delete both of these pods. So what do you think will happen if I just go ahead and delete both of these pods? What should be the impact? If anyone likes to unmute themselves, you can just say like what you expect to happen. Here's the catalog, by the way, like what the pods are basically doing, showing this.
If you delete the pod, it will automatically come back, is it right?
Right, it should automatically come back. But here's the deal with this chaos experiment, will ensure for a certain duration of time will not let these pods come back up. And that's how the pod delete experiment works. We basically choose some kind of a resource, Kubernetes resource, like a deployment, a replica set, something like that. We go ahead and delete the pods from that resource. And for a certain duration of time, they stay deleted. And in that duration, we basically try to validate a few test conditions. That is your hypothesis. So we are trying to say that, hey, if I say delete 5 pods or 10 pods out of my deployment, my endpoint or like my website should still be usable. That is my hypothesis validation. But how will you validate that whether it is happening or not? That is where like LitmusChaos comes into play. It actually goes ahead and create that scenario and tests whether the condition is still holding valid or not. So in our case, of course, we are just going to delete both of these and let's see what it does actually for us. So I'll show you first of all how to create different experiments using LitmusChaos. Like say we have our Chaos Hub over here. Let me just delete it. Sorry, like let me just create an experiment here. Okay, so as part of this, like how you can basically create your chaos workflows. Well, in order to create your own chaos workflows, it is very simple. You can basically just go ahead and add a new experiment over here. So what is the experiment that we are trying to do over here? Well, it is a pod delete experiment. So you'd search for a pod delete here. And as you can see under generic, we have the pod delete experiment. You'll simply add it over here. As we are adding pod delete experiment, as you can see, we have an option for edit sequence over here. Just keep a note of it because in the next chaos workflow, we'll be using it. So let me just go ahead and tune this chaos experiment. By tuning, I mean that what we are actually setting up over here is we are defining our target application. The target application in this case is basically the SockShop application that we have. So I'll use the application namespace as SockShop. It is a kind of deployment as we saw here. And then we are going to specify its label. So the label actually is name is equal to catalog. Okay, let me just search name is equal to catalog. Yeah, I see it. Name is equal to catalog. Once we have defined our target application, we need to right now specify the probes. So if you remember, probes are nothing but declarative hypothesis check for our applications. So what I mean by that, let me just define a probe. It will be kind of an HTTP probe, and I'll say, let's say catalog probe. And this will be an on chaos type of probe. We have different probe modes, like you have start of the test, end of the test, edge, that is both start and end. You have continuous, that is from the start of the chaos experiment to the end, and on chaos, that is only through the chaos interval duration. So let us go with on chaos since we only need to validate in case of while the pods are actually getting deleted. Let us set a timeout of, let's say, 3 seconds, and we must retry for 2 times at an interval of 3 seconds. So what are we setting this timeout retry and interval for? Well, we have a URL over here. So this category, like whatever information you are seeing over here, is actually getting served by this API. What you're seeing is the catalog API. Okay. So the catalog API is basically responsible for serving this entire page. The pods that you're seeing over here as part of deployment are responsible for serving this API, this API endpoint, which is providing this JSON response, which is causing this page to come up. So what I'll do is, if we are deleting the pod, the idea should be that this URL is not supposed to be reachable. So I'm just putting this URL over here. And what are we trying to validate over here is that while we are deleting these pods, is this URL still reachable or not? Or more specifically, we are defining a condition over here is that when we are performing a GET request on this endpoint, are we getting a response code of 200 or not? So if we are getting a response code of 200, we can say that, okay, our application is still good because this endpoint is reachable and we are relatively fine. But even after, let's say, with a timeout of 3 seconds, retrying for 2 times at an interval of 3 seconds, we are not able to reach this endpoint, then we can certainly say that, well, our application is in fact not resilient because our endpoint is not reachable. So let us try to see like what happens if I add this probe. So at the moment, as you can see, this web page is still reachable, no issues whatsoever, because our application is right now in a perfectly stable condition. But let's see what we can do over here. Right now we are trying to tune the experiment. So here's some metrics, like what is the total chaos duration or the chaos interval for which the chaos should continue. And then you have the pods affected percentage. So as you saw, like in this deployment, the catalog deployment, we have 2 pods, right? So if we are looking forward to deleting both of these, we just need to say 100, because 100% is referring to 2 pods. But let's say we are giving 50, so that would have referred to 1 pod. So one would have been deleted. So let's just delete both the pods and see how it does. Let's just go ahead and create the revert schedule as false. Just a second, let me just see whether our pods are still here or not, so that we don't get a pod scheduling error out of too many pods. Okay, we can still delete a few pods. Let me just go ahead and quickly delete them, after which we can start this chaos experiment. So let me just delete the completed ones. Otherwise, we can get started with the experiment, the actual experiment. Okay, the pods are actually deleted. So what I'll do is I'll put this this deployment on watch, so that you can see when the deployments will actually go down. This catalog port will actually go down. Okay, so let us start with the experiment. Oh yeah, before we go into it, like what we were explaining earlier for the resiliency score, you can attach a weight to each of your experiments. So since we have only one experiment right now, 10 is fine. But let's say you have more than one experiment, you can attach a particular weight to it, so that while calculating the resiliency score, that particular weightage will be taken into consideration. Let us go next. So we are at the schedule right now. Schedule is basically responsible for ensuring that what you want to do with the workflow that you're creating. Like you want to run it only once, or you want to run it as a recurring schedule, so on. So I guess we are good with that. Let us just go ahead and schedule our chaos experiment. Okay, finally decided to come up. Fine. Let's just click over finish over here, and it should actually cause the workflow to start. Sorry for the unexpected things. So our workflow has actually started. Let me guide you through like what is happening over here. As the workflow has already started, we have the install Kiosk Experiment step right now going on. And this is the visual representation of all the steps that we'll be having as part of this workflow. Right now, we are actually installing the pod delete experiment within our Kubernetes cluster. So we have this Kubernetes cluster with us. We are installing the pod delete experiment right now. And once it is done installing the experiment, we'll just go ahead and start the experiment. Like it will go ahead and start the experiment. Okay, so looks like the experiment is about to start. Okay, the experiment has started. So I'll again just go ahead and try to look for the deployment pod over here. Put it on watch. Okay, so right now we are actively watching for all the deployments in the sock shop namespace. Up until this point, like we can see the catalog pod is still here. But as we proceed on with the experiment, as you can see right now, the pods are actually gone. Both of these pods are deleted. And as you can see, the pods are not coming up by themselves. There are 0 available pods. To confirm this, let's just simply reload this application. And as you can see, the catalog is gone. We are not able to see the catalog. And therefore, we can be sure that, yeah, it's actually not working. We have broken the application. And we can also observe the same behavior using our monitoring dashboards. If I go to the sock shop dashboard, if you remember, we are right now deleting the catalog pods. So let us try to see the metrics for the catalog. It's fetching the metrics. Okay, that is taking a while. Let me see if I can show you the same thing on Grafana, because we also have a Grafana dashboard that I've set up for you. It's happening. Okay, so the Grafana dashboard is apparently working. Not sure what happened to Litmus. I guess it is because I have chosen a bit small cluster. I guess we are not able to sustain the load of the of all the things that are working over here. So what I was actually trying to show you is this catalog QPS. Since we have deleted the catalog pod, we are actually not able to see we are able to see that the queries per second for the catalog pod is actually going down. You can see that there is a sharp decline over here, and we are actually not able to see anything beyond this point. So this actually goes on to show that while orders is fine, everything else is fine, the catalog pod is actually going down, and we are not able to therefore see any movement beyond that point. Let us try to see if our application dashboard here is actually decided to come up or not. It's taking a while to fetch the metrics. The pod is still down. So this is the annotation basically. The Kiosk Exporter has enabled this, like whatever the orange annotation you saw, that is because of the Kiosk, that is indicating the Kiosk interval. Okay, the metrics is not working. I'm not sure why, but okay, anyway, we are able to see it over here, so it's fine. Let us have a look at our Kiosk workflow. Meanwhile, it is still running, it seems. And our application pods are okay. It's back. As you can see, since the chaos interval is right now over, we had set a 30-second interval, it's over. So our pods are back in order right now. Sweet. So let us wait for a while for this experiment to stop, or basically go to an end. And meanwhile, if you have any questions, please feel free. Fine. So if you have no questions, I'll lead you through the logs of this experiment. So let's say that right now you have a problem with your application resiliency. You saw that it failed. But it's also important to understand that why your application failed, or basically why this particular experiment failed. So if we take a look at the logs, we'll be able to understand more about what's going on during the chaos beyond just the observability. So as you can see in the logs, we have defined our proofs and the proof validation is taking place over here. We are waiting for chaos interval of 30 seconds after we have deleted the 2 pods. So the status of the pods, like we are able to see the different pods that we had earlier from the catalog. This is the first pod. This is the second pod. We have deleted both of them and we are waiting for 30 seconds. During that time, we are actually trying to get the response code for that particular URL that we had set up. And as you can see, the actual value is 500 and not 200. So since it is 500, well, the pro validation is actually failing because we are expecting a response code of 200. So that is how it goes. Like we are then again restarting our pods, and the pro validation has actually failed. That is what has been indicated over here, because of which the experiment is failing. And we also we have something known as a Kiosk Result, which is a custom resource inside our Kubernetes for Litmus. So here it is an aggregation of basically all the experiment runs that we are doing. So over here as well, like it is a summary of what has happened over here. And if you can see over here, it says that the experiment is completed, but the verdict is failed, since the probe success percentage is 0, and the type of the probe that was used was an HTTP probe. So yeah, that basically sums up that why this failure happened. Okay, so if we don't have any questions, then I'll move to our second workflow. Cool. Let's just move to our second workflow. So the second workflow that I'm going to show you is a multi-cloud chaos workflow. So as part of this, what we are going to do? Well, we have a virtual machine, an EC2 instance running in AWS, and we have a virtual machine running in GCP as well, the one that I've ticked over here, as well as we have a GCP disk over here, like a persistent disk. Let me just open that. So what we are going to do as part of this is that we are will be trying to basically kill we are going to stop this GCP VM instance and the AWS EC2 machine, as well as detach this GCP disk from its virtual machine as part of this chaos experiment. So we are going to do it as part of single chaos workflow, and I'm going to show you that how you can do it. So basically what we can do is, let me just exit our sock shop application and the Grafana dashboard, since we'll be not needing it anymore. And yeah, let's just go ahead with the experiment. So let's just, what I'm going to do is, I've actually already created a multi-cloud chaos workflow as a template. Like I had run this experiment before, and I've created a template for you. You can basically create these templates that will be handy with you if you are running a chaos workflow multiple times. Anyway, you can create a schedule out of them, but you can also save them as a template. So if I go ahead, let me just show you how a template can be useful for you. So if I just go ahead, you can see that this template is actually saving all the information that we want to have over here. As part of this experiment, you can see we'll be first of all installing these 3 experiments: EC2 terminate via ID, GCP VM instance stop, and VM disk loss. And then we'll be running the EC2 experiment first, and after that, both the GCP experiments. But what's special about this GCP experiments execution is that they are running in parallel. So the steps of the execution are very much similar to what this graph actually is representing. First of all, your EC2 experiment will be running in singular, and then you'll be running both the GCP experiments in parallel. So why would we actually even need to run experiments in parallel? Well, when you are running, when basically you are running things in the cloud native space, it's very common for things to go wrong at the same time. Like, let's say you have application dependencies through microservices, and the failure of one microservice can cause a cascading failure of all the other microservices. So how will you simulate such a scenario here in Litmus? Well, this is the answer to it. Basically, you can tune your own workflows to do that. So how you can create these workflows? Well, if you go here in edit sequence, as you can see, you can either pull these experiments below, like take them to different tiers, or you can basically like create a serial workflow out of them. So in parallel, right now we have GCP2 experiments in parallel, so they are appearing as such over here. So I'll just save the changes over here. And I have also configured these experiments basically. So for the Ec2 experiment, let me just quickly run you through that what we are going to configure over here. I haven't defined any probes, but what I've defined is actually the Ec2 instance ID. So if I go over here, we have a Ec2 instance ID. And if we come back over here, it is the same instance ID that we have defined over here. And we also need to define the region over here, which has been defined. And then we are specifying that it is not a managed node group, like it is not a part of an auto scaling group, etc. Once you provide all this, there is a last piece of information that you also need to provide. So this like AWS cloud, it is basically an external entity. It is not inside your Kubernetes. So how will we authenticate our LitmusChaos application or the experiment with AWS? To do that, we are actually using an IAM role basically as part of a secret. So we basically create a Kubernetes secret containing the credentials that we need in order to authenticate with our AWS cloud and mount it as such. So I'll be just like to show you that how you are able to mount all that. Like if I go to edit YAML, by the way, what is this document? Let me just go through that as well. So as you can see, this is of kind workflow. So it is actually the workflow custom resource, the Argo workflow custom resource that is actually mitigated by our workflow controller in the execution plane. So while we are creating all these information in the Kiosk Center, it leads to the creation of this manifest, this entire manifest. The outcome of everything that we are doing as part of the creation of this Kiosk workflow is nothing but this manifest, which is actually getting forwarded to the subscriber and eventually to the workflow custom resource, workflow controller in the execution plane for the orchestration of chaos in your Kubernetes cluster. So anyway, if you take a look at this workflow resource, as you can see, we have a secret over here, and it says AWS Cloud Secret, which will be mounted at a path temporary. So I have actually already created that secret. I can actually show you. So if I say kubectl get secrets dash and litmus, this should actually list all the secrets that we have in the Litmus namespace. And as you can see, we have a AWS cloud secret. So it takes the AWS access key and the access key ID as part of the secret, mounts it in the temp directory from where we are actually able to fetch it inside the experiment. So anyway, let's just go ahead and see so let's just go ahead and proceed with the GCP experiments and see how they work. They actually also work in a very similar fashion. Like they also require a secret in order to mount the different credentials you would need to authenticate with your GCP cloud. But apart from that, based on the experiment, like if you're doing a VM instance job experiment, you need to provide your VM instance name, which I've already done over here, the project ID of your GCP, and then you need to provide your instance zone as well. And then also provide like it is a part of an auto scaling group or not. So these are all the things that you need. And I've also mounted a secret for it. I'm not going to show you for the VM disk loss. Well, it is the exact same thing. You just need to provide the name of the disk, so on and so forth. So with that, let's just actually go next and try to schedule our experiment. As you can see here in the resiliency score adjustment, you can set up different weights for each one of them, so that if some experiment is having like more importance, then the resiliency score for it will be calculated accordingly. So for the timing, let's just keep everything to full. Let's just go next. And yeah, we are actually ready for the experiment. So let's just start the experiment. So as part of this experiment, well, the Litmus will actually go ahead and first of all install all the Kiosk experiments that we have. Let's just wait for the experiments to start. Meanwhile, if you have any questions, please feel free. If I skipped over some step, please feel free. Let's wait for the Kiosk Experiments to finish their installation. Okay, so we are right now starting with our first experiment, that is the EC2 terminate by ID. The experiment has already started, and the only way to confirm that whether this experiment is actually working or not is by actually going to the AWS console and see that whether our instance is actually like still running or not. Like before the experiment, of course, it was running. If I refresh this, as you can see, it is right now already stopping. So this actually confirms that we are able to successfully inject Kiosk into our AWS cloud resources using LitmusChaos. So what is the significance of this? Well, you can have your different cloud resources, not only VM instances, you can have your EBS resources or any kind of other cloud resources running as part of your AWS cloud. It can very well be singular virtual machines, or even a fleet of managed virtual machines. And it's very much it's very much like required to validate the resiliency of these VMs, because you need to be sure that while in the event that some VMs are actually going down, or even AWS cloud is having an outage where the VMs stop working, your application still stays afloat. It is not affected by any means. So it is an excellent way to test this out. By the way, as part of this experiment, I'm just targeting one VM over here, but you can do this for n number of VMs. This is something that LitmusChaos is very well able to do, that is scale up or scale down in a very efficient way. It can efficiently scale up for hundreds of VMs at a go as well. It can handle them. So we have to wait for some time. Like I've set the chaos interval as 30 seconds. So we would have to wait until the chaos interval has, okay, the chaos interval has already passed as we were talking. So it is back to a running state, and this should actually mark our experiment as passed, because even after stopping our AWS EC2 instance, it came back to a running instance. And since we didn't had any probe validation, so everything basically got cleared and we are good over here. Okay, with that, we should actually be heading to our next experiment, that is the GCP experiment, as soon as our EC2 experiments. So you must be wondering, like, what's taking it so long to finish? It's actually like we are currently updating our chaos result and stuff, because it's not only about stopping or starting the EC2 instances, it's also about maintaining the chaos result, where we are aggregating the results of all the chaos runs. So we need to be able to make sure that we are recording the outcomes of this experiment. So yeah, that's done. Now let's just start with our GCP Chaos Experiments. So we can see that already our GCP Chaos Experiments had started. We first of all have our VM instance stop experiment. So as part of this experiment, we are actually seeing that our VM instance is still running. And if I go to the disk, we are actually targeting this disk. And it is right now attached to a VM instance over here. So right now, since our experiment is running, let us refresh and see if this instance is still running or not. So if I refresh over here, as you can see, the instance is right now stopped, and it is the experiment that caused it to go from a running to stop state. And same here, if I refresh this, just keep an eye out on this test disk. If I refresh this, as you can see right now, it's not attached to our VM anymore. So what are the implications of these experiments? Well, with the GCP VM instance stop experiment, it's the same as AWS experiment, but here in GCP. And with the disk detach experiment, well, you might have a few different databases or important applications running using your persistent disks. So in the event that a disk goes detached, or basically some data corruption happens from the GCP sites, or anything that causes the disk to not work for you, how can you be sure that basically all your data is still secure and backed up, and no harm is inflicted on your application. So these two experiments can basically help you in validating those scenarios by creating the actual circumstances where you are effectively creating the outages at the same time for everything. Like, as you can see, at the same time we are stopping the instances and the disks as well. So yeah, basically we should again right now see the instances come back up. The experiment is still running, but we would have to wait for 30 seconds. Let's see if they are back or not. Okay, the instance is actually running right now. Like, it has already started again. So our disks should be also good, like only a disk, test disk. If I refresh it, yeah, as you can see, it is right now again connected to our instance. So these two experiments have also passed with flying colors, since we were able to revert everything after we stopped our VM and detached our disk. We were again able to start back up the instance and attach our disk. So yeah, with that, basically we can see that all the steps of the experiment is successful. So we achieved a 100% score, I guess. If we go to a table view, yeah, we achieved a 100% resiliency score. Cool. So we came a lot across the last few minutes. We saw the different capabilities of LitmusChaos. If you have any questions, anything at all for me before we proceed on to our last Chaos workflow, I would like to take them. If you have any questions.
Nilanjan, this is Sandeep again.
Sure. Yeah.
So for connecting to Kubernetes, we use Litmus CTL, right? So if I
Yeah.
want to run VM-based workloads in GCP projects, so how are we going to connect to the project, and how are we going to configure that?
Okay, let me just show you that part again. I'll just go from the scratch. Like, I used a template right now. I'll be not doing that, just to show you that how that part can be done. So you have setup over here right now, and Litmus setup into it. Nothing more than that. Like, we don't have anything more. So I'll just go to the schedule workflow, choose self agent, choose next, and then we'll just choose the Chaos Hub. So Chaos Hub, if you remember, is the open source marketplace, and inside that we have our default hub, the Litmus Chaos Hub. We'll go next. You can name it anything, like let's just say GCP from now. And if we go next, you can add new experiments from here. So I'll just search for the GCP experiment. Let's just say that we want to use the GCP VM instance shop experiment. So I'll add it. And upon adding it, you'll be able to tune this experiment. How to tune it? You can basically click on this pencil icon, or basically click here on the experiment name, and then you can have different options over here. Like, first of all, the name of the hub and the experiment name, etc. Then you can specify the target application. So this, since this is not a K8's like experiment, so it's not really relevant for us, but you can still enforce an annotation check, which is not really important in this case. Next, we are going to go with any probes that you want to define. Like, as you saw in the pod delete experiment, I had added a HTTP probe. You can do the same thing over here. Like, let's say your VM is running some kind of a server into it. So you can give the public URL of that server. While your VM will go down, you'll be able to see that whether that URL is still applicable or not. Or even you can plan for even complex scenarios where you have a load balancer serving some URL, which is dividing the load between some VMs, and basically you can disable a percentage of the VMs or a particular VMs out of that load balancer and see whether they are still working or not, something like that. But anyway, I'll not go into the probes right now. And lastly we come to your question, that how you can specify the chaos injection on my cloud resources. So for example, here is my project, Litmus E2E, and here is my VM instance, nail test instance. So I'll just copy the name of the VM instance over here. And as you can see over here, while tuning the experiments, you have a few tunables over here. That is the options that you need to configure. You have your chaos duration, the chaos interval, that is the time duration for which you want to like stop these GCP instances. Then you can specify the name of your VM instance. So here I'll put in the name of the VM instance that I just copied. Then the GCP project ID, that is basically the project that I have. Like, this is the ID of my project. and you need to put it there. Then just put in the instance zone, that is your central 1A. And that's it basically mostly. You can also make this enable if you have an auto scaling group, but that VM is not auto scaling group, so I'll not do that. I'll not run this experiment right now, but here is how you can specify. And one last piece of information, that is how you will authenticate with your GCP account. Well, for that, basically you need to create a GCP service account. What this GCP service account will do is it will let your this Kubernetes experiment, sorry, this LitmusChaos experiment to impersonate an IAM identity basically, and then it can make requests on behalf of basically that IAM role that has been assigned to it. Like it will have all those permissions. So I have actually already created all that. Like I had listed my secrets a while ago. So
Got it.
yeah, so basically that's how you provide the permissions. Cool. Okay, I'll revert this experiments. So with that, let's just move to our last demo for today. What we'll be doing is we'll be making use of in-VM chaos. What I mean by is that we'll be trying to go inside a virtual machine and then perform a process kill experiment. The name should be very much indicative of what we are going to do. We are going to go inside a virtual machine, kill basically a process over there, and that will be the basically our chaos experiment. So in order to do so, what we can do, well, think from a technical standpoint that we have Kubernetes right now, and we are trying to orchestrate chaos within a virtual machine. That is, we are trying to access the internals of the virtual machine, the operating system, the let's say the disk or IO, whatever components there are. So how would you do that? Basically, in order to mitigate the same issue, in order to have a superior observability and have different features that we can integrate during machine chaos, we use M-Agent. So what is M-Agent? Well, what I'm going to do is, let me just go inside this VM, like what we are using over here. Like whatever process we'll be using are inside this VM only. So let me just first of all SSH into it so that I can show you what we are going to do here. So while we are SSHing into it, let me just go ahead and create our Kiosk experiment. So I'll again choose this self agent. And in this case, I'll be actually using my own hub. So the thing is that the experiment that I'm going to show you is still not GA. Like we are still not making the charts available just yet, but you can be sure that in the further iterations, we'll be definitely going ahead with it. Like you can still use this experiment from my hub, like from my own hub. But again, please don't do that, because if there are any inconsistencies right now, that might affect your system. So let me just still show you that how it can be used. So if you have, like I have selected my own hub, and what it will do is basically it will let us basically choose the process kill experiment. So if I say process kill over here, it lets me choose it. Meanwhile, as you can see, before I start and going ahead with the configuration, we are into my virtual machine right now. So I was talking about M-Agent. So, well, what is M-Agent? First of all, let me talk about it. M-Agent is a machine scoped, or basically VM scoped agent, a daemon agent, which helps you remotely inject faults within your virtual machines, bare metal nodes, or even physical machines. So it is basically a daemon agent, that is, it is managed completely by your own operating system, and it helps you to remotely inject faults in background using LitmusChaos experiments. So what I'm trying to say is that M-Agent is basically installed within this virtual machine as part of a binary, and we can interact with the M-Agent in order to inject chaos, like process kill chaos, for example, into our machine. So if I want to right now specify M-Agent to, let's say, perform the process kill experiment, so we can, like the process is very similar to what we are doing so far. Like I'm coming to Chaos Center over here, I'm choosing the process kill experiment, but there are a few more steps. what are those steps? Well, first of all, the problem is like we need to specify that we need to yeah, sorry. So we need to basically specify that which process IDs that we are trying to kill. Well, that should be simple. Like I have already installed an Apache server here for you, and we'll be killing the Apache server over here for our experiment. So if I say systemctl status Apache 2, you can see that the Apache 2 like is a process is already here. It has a PID of 390. So let me copy it and provide it over here. Now the issue is, how will we actually communicate with our agent? So the agent, as the name suggests, is nothing but a entity which performs chaos on behalf of our Litmus Chaos experiments. That is, Litmus Chaos or our experiment pod will be actually talking to the M agent that is sitting right inside our virtual machine. And we are supposed to basically tell M agent that, hey, just go ahead and delete this process. Process with the process ID of 390. So in order to do that, basically we need two things. First of all, you need an agent endpoint as well as an auth token. The agent endpoint is nothing but basically the URL of your agent, because you need to specify basically at which point like you want to communicate, like at which endpoint you want to communicate, and the auth token, so that you can basically authenticate your machine for all the requests that are being sent from this experiment pod while we are running the experiment. So the question is, how will you generate this agent endpoint and auth token in a safe way? Well, that's where mAgent is first comes in, because it can be used, we can use it as a CLI tool over here. So if I say mAgent and then issue the flag get token, it prompts me that the token should expire after what time, since it's not a good practice to generate long running tokens that don't expire, since they can potentially be compromised. Let us take a token for, let's do 30 minutes only, since it's a short demo. So this token that we are getting over here is our authentication token, which will be actually valid for a duration of 30 minutes only, which you can use to authenticate your Kiosk experiment. And apart from that, it is also providing us with an agent endpoint. Well, this is nothing but basically your the public URL of the VM that we are using right now. So if I go over here, here's the public URL, like as you can see, 34.134.78.28 is the same value over here, added with the port. So mAgent is actually utilizing a port at which our experiment pod will try to connect. So both of these pieces of information make up our agent endpoint. So what I'm doing right now is I'm just copying over my agent endpoint as well as authentication token into my basically the secret that I'll be mounting right now. So what I'm going to do is basically I've set up this secret. It has this agent endpoint as well as this auth token, and it is a simple secret. So I'll just apply the secret now. kubectl apply agent secret in the Litmus namespace. Let's wait for it to get applied. And while it is applying, let's just move ahead. Since we are providing both of this information as part of a secret, we can basically just move ahead. Basically, that's all you need to set up. Like if you're using mAgent, the first thing that you need to do is basically set up your mAgent within the VM that you want to injecting the chaos into. It's a simple installer script that you can basically access at github.com/litmuschaos/mAgent. There you will have the entire guide to how to set up mAgent. And once it is set up, you just need to say mAgent get token, and you'll get the both pieces of information. You need to create a secret out of it so that in subsequent runs you are safe against any security compromise. And then basically you just need to set up your own Kubernetes experiment over here. So I'll just go ahead and yeah, we can set the weight as 10. You can simply schedule the experiment now. With that, let's just finish. Yeah, go to workflow. So, okay, we have a warning over here. Seems like there has been some issue in workflow running from, oh, I don't know what is this. Since we already started the workflow right now, I don't think it was a false message. So yeah, we have the experiment started over here. The process skill experiment is actually starting right now. So how can we basically see whether the our Apache is working or not? Well, what I'll do is I'll say watch system CTL status Apache 2. So this will let us watch like the status of Apache 2. So as you can see, it is running right now, like it is still running. And we are just about to get started with our process skill experiment. So we'll just keep an eye out for here, like the status is active, it is still running. But the process skill experiment has actually started. So let's just see. Okay, and as you can see, as soon as our experiment is actually started, it actually went from active to deactivated, and the signal that we got is actually stop sig term. So, and if we like further see over here, it says that Apache 2.service main process exited because we just killed the main process over here. It also goes on to say like code killed signal is equal to kill, and we can confirm that using this message. So yeah, this goes on to prove that the experiment was actually successful, or basically the chaos injection was successful. We have successfully actually killed our Apache process. And yeah, basically the possibilities for M agent is limitless. Like this is only the beginning of our interaction with M agent, and we are excited about creating more such experiments with M agent. We can basically create faults for processes, CPUs. We can also do it for application types of chaos like JVM chaos, etc. That is definitely in our roadmap. So yeah, we'll just give it some time to uh, complete this experiment. Meanwhile, if you have any questions about M agent or anything, I'll be happy to take them. Okay, great. Basically, this experiment will go on for more 30 seconds, I guess. We can wait up until that point, but yeah, mostly that's it for this demonstration. This was the last demonstration of the LitmusChaos workflow that I had for you. It was actually completed. And yeah, as part of the revert chaos, we are basically removing the experiment pod or the chaos workflow pod, etc. So that process is also completed. So yeah, guys, that is it basically for this demo. We had a lot of learning today, starting from the basics of chaos engineering. Why do we need chaos engineering, or what it seeks to achieve? What are the processes that we are using inside chaos engineering, to the very core of LitmusChaos? We explored LitmusChaos in a very comprehensive way, in depth, and we saw different workflows that we did using AWS, GCP, Kubernetes, and even machine scope resources. So yeah, guys, I hope it was a learning experience for you, a great experience for you, because I know it was a great experience for me having you guys with me over here. So with that, I would like to close this session. Thank you so much. And if you guys still have any questions, please feel free.
Thanks a lot, everyone, for joining in. I think it was great having you, and I hope you folks have joined the Slack. And
thank you very much.
We'll look forward to more questions.